Okay, last week we started the topic of traffic flow stream, and we discussed that there are two types of traffic flow facilities: interrupted, uninterrupted. Then there are two types of traffic stream parameters, which is macroscopic and microscopic. In macroscopic parameters, we have volume, flow, and rate of flow. All three of them are linked with each other. And other macroscopic parameters include speed and density. When we say speed, we are saying mean speed. It can be space mean speed or time mean speed. Then we have microscopic parameters, which include speed of individual vehicles, headway, and spacing. We looked at some equations which interlink these parameters together. For example, if you know spacing, you can find out density. If you know headway, you can find out flow rate. And if you know both of them, you can find out speed. Okay? And this is another relationship between the three parameters: flow rate, speed, and density. Okay? So, in which category of parameters all of them fall? Which type of parameters are these three? Flow, speed, density. Macroscopic. Okay, all three of them belong to the macroscopic category, and this is the basic equation of traffic flow. Okay, this is the primary equation of traffic flow, and we will look at other equations today as well. In these graphs, you see the relationship between the pair of parameters. Okay, the same three parameters. What is the link between each pair of them? So, for example, if you look at the one at the bottom, which we have already discussed as well, is between speed and density. Okay, this one is between speed and density. So you can see when density increases, what happens to speed? Decreases. And why does the speed decrease? With increase in density.
There's less space to move.
There's a space to move. Okay. So this relationship is very clear, and we have discussed it earlier as well. Okay. Any questions? Okay. Moving on to that one, which is between flow and density. Flow and density. So we start at the origin. Zero density, zero flow. No vehicles on the road, there is no flow. Okay. Then vehicles come on the road and they move. So density increases, flow also. What is happening to the flow? Increases. Until you reach the top point. What are they calling that point? But what are they calling it? Capacity. Okay, and capacity means maximum flow. Capacity is what? Maximum flow. Okay. After you have reached capacity, if you put more cars on the highway, what will happen? Traffic jam. So in traffic jam, what is decreasing? Flow or density? Flow is decreasing, right? Density is increasing. That's why the flow is decreasing, right? Because there are more cars on the road and the road cannot handle it. Okay? So the flow is decreasing and the density is increasing. You look at the dotted portion, the broken portion, this is happening. Density increasing, flow decreasing. Clear? Clear? Okay. Until you reach this point. Okay. They are calling it jam density. Now which density is this? Jam density is what? Which value is jam density?
When it's what?
Huh?
When it's what?
Yeah, but which value is it on the graph?
0.
No. Jam density is maximum density. What is 0? Flow is 0. Jam density is the maximum density. Okay? And when you reach jam, that means the flow is 0. Clear? Okay. Any questions? Okay. Then we reach the flow speed curve. Okay. Again, I'll start from 0 here. So we have 0 flow. Why? Because there are no vehicles on the road. If there are no vehicles on the road, that means the speed is max. Okay. So this is what is happening here. The speed is maximum, the flow is 0. Why it is 0? Because there are no vehicles on the road. Clear? Then vehicles come on the road, flow will increase and the speed will decrease. Okay. Again, until you will reach the maximum point, and what did we call that point? Capacity. Okay. After capacity, if more vehicles come on the road, what will happen to the flow? Decrease. And obviously, after capacity, there is a traffic jam, right? So speed will also decrease. Clear? Clear? Okay. So up till this point, the flow is increasing, only speed is decreasing. After this point, the speed and flow both are decreasing. Clear? Clear? Okay. Now in these two graphs, the top two graphs, you will see the terms critical density and critical speed, right?
Yes.
When do we reach critical density?
At the maximum point.
When the flow is maximum, the capacity. When you reach capacity, the speed at that point is critical speed, and the density at that point is critical density. Clear? Okay? And how did we define capacity? Maximum flow. So when the flow reaches maximum, the speed at that point is critical speed, and density at that point is critical density. Okay. All these three graphs, you see that there is a solid portion and there is a broken portion, right? In all the graphs, you see they are divided into a solid line and a broken line. Okay. Solid line represents stable flow. Solid line represents stable flow. Is it before the capacity or after the capacity? Check. Before capacity. So there is no traffic jam, there is no queue. That's why it is stable. That's why it is stable. Because there is no queue, so people come and they don't have to stop for anyone. Okay? After capacity, what is happening? Yeah, we call it forced flow. But why do we call it forced flow? After capacity, what is happening? What is happening on the road? Traffic jam, right? So traffic jam means now there are vehicles in front of you which are stopped. So when you enter this segment, you have to also stop. And this is how you will move. You will move a little bit, then stop. Then you will move a little bit and then stop. People who come in the morning know this, right? Okay. This is forced flow because other vehicles are forcing you to stop. Clear? Okay. Solid portion before capacity, indicating stable flow where nobody has to stop. They will move, okay, at high speed or low speed, but they will move. The broken portion, forced flow, because you come, you already find vehicles stopped in front of you, they will force you to stop. Clear? Clear? Okay. Now you see here in this graph, This is the solid portion, that means before capacity, stable flow. This one is the dotted portion after capacity, forced flow. Okay. In this portion, the speed is high, density is low. In this portion, the forced flow condition, the speed is low and the density is high. Clear? Okay. Okay. The graph which I showed you previously, it was a smooth curve, right? Between flow and speed. It was a smooth curve. Okay. This is a more realistic representation of the traffic flow. This is more accurate, more realistic. Okay, but you can see it is more complicated as well. Why we are discussing it? Because later on in some other chapter, we will look at the equations which are driven from this graph. Okay, clear? So the previous one between speed and flow was a simpler version of this. Okay, this one is more accurate but more complicated. Clear? Clear? So when we will drive the equation, we will drive for the simpler one. For this one, there are some good people who already drive the equation, they give it to us. We just use them. Okay, and pray for that. Okay? Clear? Okay, now what is this? Now if you look at this graph, see this is between speed and flow. Speed and flow. Okay? And you look at the graph on the right hand side, that is also between speed and flow. What is the main difference? Look at this one and this one, apart from the axis. They shifted the axis. Look at the shape of the graph. What is the main difference here? Huh? Look at the shape of this curve and that one. This one is parabolic. And what happened to this one? Huh? Yes. Actually it is broken. The curve is broken. That's our society. That one is more realistic. This is what I say. Okay. Why it is broken? You look at the first portion, it's a straight line. The first portion is straight line. Okay, region 1. And look at region 3. Again, straight line. So this curve is broken. Okay. Why it is so? What is happening on the road? What is the actual phenomena? Drivers tend to be aggressive. Okay, especially you guys. It's a fact. People have studied you. You don't know what they have studied. You are an old man. I'm not talking about the other people. Okay. So what happens when flow increases? Drivers do not immediately reduce their speed. When flow increases, they see more cars around them. They do not immediately reduce their speed. They will maintain the same speed even if the spacing is less, because they think they can manage. Until you hear the crash, you are managing, right? Huh? Right or wrong? Once I was sitting beside my friend and he was reversing. He told me, he was asking me, could I do more? I said, when you hear the crash, then you stop. And he did. Like, he actually did it. Like, he actually crashed. And then he stopped. Okay? So this is how things are. So this is the first portion, the straight line. Okay? Flow is increasing. See? Flow is increasing. But the speed is same. Okay? No drop in speed. Until you reach a point, they call it the break point. So up till break point, there is an increase in flow, but Okay, increase in flow, no decrease in speed. Okay, then from the break point till point 2, you see the curve. You can see the curve. So flow is increasing, speed is decreasing. The same, the thing which we were expecting earlier. Okay, and this happens till what point? Capacity. And capacity is what?
Maximum flow.
Maximum flow. So until you reach maximum flow, then you will have this from the break point till capacity, you will see the depth of speed with respect to flow. Okay, then you have region 3. Okay, from point 2 to point 3, you see a sharp decrease in what? The speed is suddenly very low now, right? Between point 2 and point 3, the difference in speed is very high. Okay, but what about the difference in flow? Not so much. Okay, the flow is almost same, but the speed has suddenly dipped. Okay, so what was happening here? Until point 2, you can see the speed is very high, right? After point 2, after you have reached capacity, so there is a Q now. So you are coming at very high speed. Okay, you are expecting that I will move at that speed, but when you reach the segment, you saw there are 2 or 3 cars stopped in front of you. So suddenly from 100 you may go up to, you may have to stop basically. Okay, you may have to stop. Clear? So this is this portion. Region 3. When the capacity has just been breached, okay, so you have just gone beyond capacity, just now the traffic jam has started, but the drivers are coming at very high speed and they are joining the queue. So when they join the queue, they go from very high to very low. So they are coming at here at this speed, then suddenly they drop to this one. Clear? Clear? Okay. Then after this, again the expected phenomena, the flow keeps on decreasing because the queue is getting longer, and the speed also keeps on decreasing. Clear? Okay. Any questions? In this graph, you see another term which is the free flow speed. So which speed is this? Meaning what? Which value is it on the graph? Maximum speed. So the maximum speed is called as what? Free flow speed. Okay? Clear? So now we know 5 important terms. We know capacity, which is what? Maximum flow. We know jam density, which is maximum density. We know free flow speed, which is maximum speed. We know critical density. When you reach capacity density at that point. And we know critical speed, which is again when you reach capacity speed at that point. Clear? Clear? Okay. So now we start talking about traffic flow theory. What is the theory?
Assumption.
It's an assumption about?
Scientific fact.
Yes. A phenomena which is happening naturally, an assumption or a theory about it is supposed to explain it, why it is so, why this is happening in this way. Okay, and until you prove it, it's a theory. And you prove it, it becomes a law or a rule or a fact, whatever you call it. Okay, clear? So traffic flow theory is supposed to explain the flow of vehicles, the equations, the models which explain the traffic flow. We call it traffic flow theory. Okay, clear? And this theory, the first, you can call it the founder of the traffic flow theory was Mr. Bruce Greenshields. Okay, He's my childhood friend. We used to play together in 1930s. Okay. At least some of you are smiling, right? So you don't believe it, no? Good. Okay. So in 1930s, when they did not have any vehicles, he was coming up with traffic flow theory to make our lives miserable. Okay. So what did he come up with? He started with the most basic relationship, the easiest one, between density and speed. So he collected some data, he plotted the data between speed and density, and he said that this data follows a straight line. Okay, so you can see the points in the graph, and these points are joined by a straight line. Okay, this was the assumption at that time. Okay, so to have the relationship between speed and density, then I need the equation of a straight line. What is the equation of a straight line? Tell me. Yes. Huh? Ax plus b. So y equals ax plus b. Now look at the graph. What is my y? Speed. What is my x? Density. What is my b? Huh? Look at the graph. Equation of a straight line. 65. What is 65? Y-intercept. Okay. B is y-intercept, which is, if you look at the graph, it is 65. For this graph, it is 65. We are all talking about this graph. It's a 2D graph. There is no flow here right now. Clear? Clear? Okay. What is my A? What is A supposed to be? Huh? Delta y over delta x. Slope, right? Slope. Okay. So y upon x. My y is how much? What is my y? 65. My x is how much? 110. Okay. I'm just talking about this graph right now. Okay. So and y minus?
Doctor, delta x is 110.
Okay, why did I put a minus here? Yeah, because the slope is going down. Clear? Clear? Okay. So if you take 65 as common denominator from the equation, you will get the equation which is shown on the graph. Okay, so it was actually this equation. Okay, and he took 65 as common, so it is simplified now in this way. Clear? Clear? Any problem? Okay. Now, what is 65? Maximum speed, right? 65 is maximum speed, and what did we call it? Free flow speed. And 110 is what? Maximum density, and we call it what? Jam density. Okay, clear till now? Okay. You look at that equation, the one which I showed you last week. Flow equals speed into density. Okay. Now, which speed are we talking about? We have talked about two speeds. Space means speed, time means speed. Which one it is? Yeah, it's always space means speed. Okay. Clear? Okay. So I have a relationship between speed and density, the one which I did from the last graph. Okay, and I know this one as well. Okay, so I have now two equations. From the first equation, I can replace S. So S equals to what?
D over D.
Huh?
D over D.
B over D. Okay, so I will take the value of S from here, V upon D, and put it in this equation. Okay, so this equation becomes between flow and density. If you put D on the other side, you will get this one. Clear? Any problems? Okay, we did it from the graph. This one we already know. So from here, I took the value of S and put it in this one. So the equation becomes between flow and density, and this is the equation. Clear? Okay. Then I go back to the first equation again. Now I want to replace D. So D equals to what? V over S. So from this equation, I replace D with V over S. So the equation becomes between flow and speed. Okay, if you open the bracket and take all the ratios and so on, this is the final equation. Clear? Any questions? Anybody have any problems?
Yeah.
Yes.
Why we do this? Why we do this?
We need the equations between all the three parameters, right? I only had the equation between flow and speed and density, right?
Yes.
But I need the equation between flow and speed as well, and flow and density as well. Clear? Okay. So now I want to find out capacity. Okay, I want to find out capacity. Capacity was what? Maximum flow. Now you look at the flow equations. There are two flow equations, right? Flow and speed, flow and density, right? What is the what type of graph I have between flow and speed or flow and density?
The maximum speed.
No, what type of graph I have between flow and speed? Look at the equation. It's a parabolic curve. Okay, it's a parabolic curve. So when you reach the maximum point of the curve, the slope becomes what? 0. Okay. Look at any equation of the flow. Both of them are second degree equations. Both of them are parabolic equations. So when you reach the maximum point of parabola, the slope becomes 0. Okay. So how do I get the slope? I have the equation of the parabola. Yes. So I will take the derivative. So for example, I am talking about this, the first equation. This one, between flow and density. So I can take the derivative. So derivative will be 65 minus 2 into and we said at the maximum point the slope should be what? 0. So this whole thing should be 0. So if this thing is 0, then D is what? How much is D? Give me the value. Yes. 65? 55. Okay. I had the equation between flow and density. That was a second degree equation. I am trying to find out the maximum point. At maximum point, slope is 0. To find the slope, I took the derivative and I put it equal to 0. So I found density. Yes. Yes. Okay. So this density of 55 is achieved when the slope is 0, meaning when the flow is maximum, it is capacity. So we call this density as critical density. Okay, I can put a CR here.
So it's in day or in segment?
Sorry.
It's in days or in segment? Interior segment.
All equations are per lane. By nature, they are per lane. If you want to make it to the whole segment, you have to multiply by the number of lanes, which is not there. So we by default per lane. Clear? Any other question? Okay. Now I can do the same thing with this equation, right? I can take the derivative. Okay, same thing which I did with the other equation. What is S now? 32.5. And what do we call this speed? Critical speed. Okay, meaning speed when what happens? Capacity, right? Okay, so I have to find out capacity, which is maximum flow. You have three equations by which you can do it. Okay, you have this one, which is between flow and density. Now you know when flow is maximum, density is 55. You can use this equation as well, because I know when flow is maximum, the speed is 32.5. Okay, so either you can put the critical density here, the flow will be capacity, or you can put critical speed here and the flow will be capacity. Okay, or I have another equation which is flow equals S into D. You already know what is S, you already know what is D. You put both of them, you get the capacity. Okay, use any of them, give me a value. You can use the one between flow and density, flow and speed, or the last one. 1787. Okay? Any problem? Any questions? Clear? Everything is clear? Okay. Now what type of equation I have between speed and density? Linear, right? Linear. What type of equation I have between flow and density and flow and speed? Parabolic. Okay. Now you look at D critical. Okay, D critical is how much? 55. Look at jam density. How much is it? 110, right? 55, 110. What's the relationship? Huh? Yes, half, right? Okay, so this is half of jam density. Okay, this is half of jam density. My critical speed is 32.5. 32.5. Free flow speed is 65. What's the relationship? Half. Okay. All these things will remain same for any height. Speed and density, straight line. Flow and density, parabolic. Flow and speed, parabolic. Okay. Critical is half of jam density. Critical density is half of jam density. Critical critical speed is half of free flow speed. All these things are same, whether you are doing it for highway X or Y or B or A or whatever. Okay, and the method which we apply to find out capacity again is same. You find out the slope should be equal to 0 and so on.
It's half of the free flow speed.
Yeah. Okay? Hmm?
The free flow speed is
It's 65.
maximum.
Yeah. What's your question?
Question. I think the 32.5 is the free flow speed.
65 is the free flow speed. Maximum speed on the graph. What is the maximum value here? On the y-axis. What's the maximum value? That is the free flow speed. Okay? Yes?
You multiply the jam density by the free flow speed and divide it by 2.
You cannot. You cannot. You cannot multiply jam density with free flow speed. Why?
That is free flow, this is jam.
They are happening in two different ends of the graph. So I cannot take x1 and multiply by y10. x1 multiplied by y1, right? Okay, so they are happening at different times. You cannot multiply them. So I can multiply critical with critical because both of them happen at the same time. Critical density when the flow is capacity. Critical speed when the flow is capacity. So both of them are happening at the same time. You can multiply them. Okay, but jam and free flow cannot happen at the same time. Okay, unless you have jam on the road and then you are flying in your plane at free flow speed, then it's fine. You can do whatever you want. Okay. Okay, so I told you that the relationships are same. Whether you take any highway, the relationship will be same. But let's take free flow speed. Will all highways have the same value of speed? So that means the relationships are same, but the numbers can change. Okay, the numbers can change. And then you see one example here. So they have already given us a relationship between speed and density. Okay, and you can see it's again linear, right? It's linear, but it's not the same equation. Because the numbers are different. Clear? Okay. And then we have to perform these tasks. The first task is very simple. We have to find out the free flow speed and jam density.
71.
Okay. So free flow speed was which speed? Yeah, but which point is it on the graph?
D equal to 0.
Y-intercept.
When d equals to 0, y-intercept maximum speed, right? So in this equation, if somebody doesn't know the equation, he's looking at the equation for the first time, but he should know that free flow speed happens when density is 0. You will have maximum speed when density is 0. You go to the equation and put density equals to 0. The speed you will get is the free flow speed. How much is it? 71.2. Okay, what about jam density?
122.
Which point is it on the graph? On the graph?
Speed.
X-intercept, speed is 0. Okay. So again, if somebody hasn't seen the graph, he doesn't know about the equation, but he should know jam density happens when speed is 0. You can go back to the equation, put speed equal to 0 and you can get jam density. Okay. In this case, the jam density is how much? Huh? Yeah. Jam density is 0. You can get 0, no problem. I'll give it to you in the exam. But jam density is not 0. 120. Okay. To get jam density, you will put speed equal to 0 in this equation, you get jam density. Okay, and you should be getting 120. Clear? Clear? Any problems? Okay. Now they are saying derive the other equations, the parabolic equations, flow and density, flow and speed. Okay, so to derive the other equations, I have one equation which is already given here, right? Between speed and density is already given. Okay, and then I need another equation. V equals S. Okay, so first of all, I will replace S from the given equation with V by D. Okay, so I'll put in the first equation S equals to V by D, and I will derive the equation. Okay, and then what about the other one? D equals to okay, so both of them will be put in the first equation, the given equation, one by one. First you will put this one, replace S, then you will put this one, replace D. Okay, then you will expand the equation. If there are any constants, divide, multiply, whatever, then you come up with the final equation. Okay, look at the last part. Now you have three equations: speed and density, speed and flow and speed, and flow and density. Now all three equations. Look at the last part. We have to find out the capacity. What did we do to find out the capacity? Huh? Which flow? Any flow. You have to find out critical density and critical speed. Yes. So you will take the two equations which you will make, the parabolic equations. You will take the derivative, put them equal to 0. You find out density, you find out the speed, and then you can use any of these equations. Okay. You can use this one as well. V equals to S into D. Clear? Clear? Okay. This is for your practice. Tomorrow you will bring the two parabolic equations and you will tell me the value of capacity. Okay? Capacity. Okay? So two equations and the value of capacity. Any questions? Any problems?